Hello everyone! Within this video, I'm going to be discussing my poster, Changing Seagrass Patterns in Barnegat Bay. So as a little bit of background, seagrass beds are super important habitats because they provide numerous ecosystem services, and some of those include wave attenuation, sediment stabilization, organic carbon sequestration, as well as most importantly serving as a nursery and foraging ground for different species of fish and invertebrates. So they're really important for early life history and juvenile stages for a lot of species in order for them to be birthed and kept safe and grow into juveniles that are ready to head out for adulthood in different areas. However, we're seeing a large decline of seagrasses due to a host of different problems that include anthropogenic causes of eutrophication due to urbanization, climate changes from temperature, and competitive interactions between similar types of SAV or submerged aquatic vegetation. And all of this is going to impact not only the local level, but that socioeconomic stability within that level as well. And so when it comes to Barnegat Bay, ideally we have two types of seagrasses that coexist there. We have Zastra marina, or eelgrass, and Rupiah maritima, or widgeon grass. And so these two seagrasses have inherent differences between them. So when we look at Zastra, we can see that they have a much thicker underground biomass in the root system here. The roots are thicker, longer, and more interconnected. And then when it comes to their above ground biomass, that's also larger because they have an overall higher biomass with longer and thicker shoots and blades. When we look at Rupiah, we see that they have much thinner hair-like root structures underneath, which isn't as good for holding the sediments in place, and that above they have shorter, not as thick, again more hair-like blades and shoots, which means that they're not able to help as much with wave attenuation. So we see these differences, and they're causing them to fill out different niches. So currently we're seeing Zastra being decreased throughout the bay and is dying off due to things like macroalgal blooms and competition. And as we're seeing that, we're seeing the more generalist species, Rupiah, come in and take over. But because of those differences, it can't quite satisfy the same ecological niches. So in order to assess what was going on in the bay, we sampled 10 sites along the coast of New Jersey, and we're using data from 2015, 2017, and 2019. Figure 1 down here shows Barnegat Bay Little Egg Harbor Estuary, and the red dots indicate the current sampling stations, and the white names indicate our water quality buoys that were used to collect average temperature. And we have a graph here, figure 2, which shows our average temperature as the bars, our maximum temperature up top, and our minimum temperature below for all of the years in between the studies. When it came to sampling, we would sample above and below ground seagrass biomass using cores. We would sample epiphytic coverage for individual shoot collection by scraping off anything on the blade and weighing the weight after drying. We would sample macroalgal percent cover and biomass using quarter-meter quadrats, and we would sample overall percent coverage for both species of seagrass using a 1 meter square quadrat. And so, as we did that and compared all of our results across the years, we came to discover some trends. And so, we discovered that there was an interaction between our seagrass, which is eelgrass, and macroalgal biomass. And so figure 3 here shows our eelgrass and macroalgal biomass for sites 0, 1, 3, 6, and 14. And these sites show that there is a decline in eelgrass above ground biomass when there's a bloom of macroalgae, and that's highlighted especially in 2017, where we had a pulse of macroalgae, maybe due to the increases in temperature seen in 2017 across our buoys. And we see a overall decline in eelgrass followed by an increase when macroalgae goes and calms back down. The other interaction we saw were for sites 8, 10, and 12. And so we see as macroalgae followed that same sort of pattern but less dramatic with a little increase in 2017, we see that eelgrass overall just kept increasing. And so that leads us to our second interaction, and that is eelgrass and widgeongrass biomass for sites 10, 12, and 14. And so when we look at those, we see that when there is less competition between the two species, so when we see that widgeongrass decline slightly, we see eelgrass take off because we're eliminating that competing factor, and so we're having Zastra be able to focus on other things besides competing with Rupiah. And so when we take off some of that pressure and stress of competition, it's able to truly thrive and increase its biomass pretty greatly. Now for site 15, we saw that as well. So as we see that algal biomass had a small pulse in 2017, we see that Rupiah and Zastra both responded negatively to the increase in macroalgae. However, as soon as Rupiah responded negatively, we see that Zastra again takes off because of that limit in competition. So we see that competition is a defining factor for the two of them, and that it might be able to overpower macroalgal impacts if we're able to reduce competition. The final interaction that we saw was that between Zastra and epiphytic biomass, and that follows as a general trend for the more area and above ground biomass. So as we see eelgrass increasing, we're going to see our epiphytes begin to tick up and increase at the bottom as well. And so that leads us into our discussion. So as we see temperatures increasing like we did in 2017, we suspect that there will be more macroalgal biomass, and that might lead to our trend of decreasing eelgrass. And so we might see that macroalgal blooms really shades out the seagrasses, and that leads to that decline in them. We could also see that it leads to a decline in both species, as in site 15, and this is the better case scenario, as Zastra might be able to take hold and increase as Rupiah competition decreases. And we see an overall competitive factor between the two species that as we see increasing patterns in Rupiah, we're seeing Zastra being forced to put all of its energy into competing, and it really cannot handle other stressors like epiphytic coverage or macroalgal increased coverage. And so we really need to be able to limit that competition, because the loss of Zastra would be detrimental to seagrass beds, because again, Rupiah isn't fit to handle and really make sure that all of those ecosystem services are happening to the same extent. And so the next steps for this project would be to secure funding for continued monitoring of the seagrass beds to further assess and prove the trends that were found within this study. And we should start looking at restoration ideas or ways of limiting competition between the two species so that we can increase Zastra biomass even more to ensure that we're not going to lose out on Zastra, and that it's going to be able to keep surviving, thriving, and providing those key ecosystem services within Barnegat Bay.